Well, let's take a look at what we have here. We've got the practice test for exponents. So the first thing I'm going to do is I'm going to write solutions on this. And I would encourage you to make sure that you've reviewed the rules for exponents that we've covered, and then also have your calculator. There are going to be several problems here where a calculator is going to come in handy. Let's take a look at number 1. You'll notice the bases are the same, so we can apply the product rule for exponents. The base is going to stay the same, and when we're multiplying, we add the exponents. So we're going to get 17. 11 plus 6 is 17. Done with that one. Let's take a look at this one right here. We've got a division problem, but the bases are the same, so that makes it nice. We're going to use subtraction in order to solve this. There are 4 7s on the top and 15 on the bottom. These 4 are going to cancel with 4 of those, so that's going to leave 11 on the bottom. So we have 1 over 7 to the 11th. We'll circle that. We're done with that one. And then we have power raised to another power. So remember, the base is going to stay the same here, and then when we have a power to a power, we actually multiply those. So we get 10 to the 28th. We'll continue on down here. We've got 4n to the 5th, and all of that is in parentheses, and we've raised that to a power of 3. So right now there's really an understood 1 as an exponent here. So remember, when we have a power to a power, we multiply exponents. So we're going to multiply here and here. That's going to give us 4 to the 3rd, and it's also going to give us, let's see, n to the 5 times 3. We end up with 15. We could probably leave it like this, but we may want to go ahead and change that number. This number is probably going to come up later on, but let's take a look. 4 to the 3rd, again, that means 4 times 4 times 4. Certainly welcome to use a calculator for that. 4 times 4 is 16, times 4 is 64. So probably the best way to write this answer would be 64 n to the 15th. We'll circle that. We've got that one done. And then you'll notice that these two problems are next to each other for a reason. They are almost the same. You'll notice we have a different exponent here, and we have a different coefficient here. If you are not careful with these negatives, you're going to get the wrong answer in some instances. So we really have 3 negatives, 3 4s, and 3 n squareds. So I'm going to write negative 4 to the 3rd. If we do negative 4 and we raise it to the 3rd power, we're going to end up with 3 negatives. 3 negatives would make the answer negative. You can also type that into the calculator. The answer is going to be negative 64. And we're going to raise a power to a power here. We're going to get n to the 6th. So we get 64 n to the 6th. You'll want to be really careful, especially when we have even exponents, because if you have an even number of negatives, the answer is going to turn out to be positive. So again, wouldn't be a bad idea to keep this in parentheses, throw it in your calculator, and even this one over here, number 4, put it in your calculator inside parentheses. Let's take a look at number 6. First thing we're going to do is we're going to simplify the coefficients on the top and bottom. Negative divided by a negative is positive, so we know the answer is going to be positive. We want to find the greatest common factor for 2 and 12. In other words, the largest thing that goes into both of those. 2 goes in here once, and 2 goes in here 6 times. So we've got a 1 on the top and a 6 on the bottom. And then let's take a look at what happens here. We've got 4 x's on the top, we've got x to the 4th on the top, and x to the 4th on the bottom. That means all of these are going to cancel, and don't forget, when we cancel everything, when we've got a multiplication or a division problem, there's always a 1 left. I could write another 1. I could write a times 1 both on the top and the bottom, but it's usually just easier to leave this and just write the answer as 1/6. So after all of that, the answer is just the fraction 1/6. Let's take a look at the next one, number 7. We've got some coefficients here. We'll go ahead and multiply those together. So we have negative 3 times 2. That's going to be negative 6. We've got x squared times x to the 4th. Same base. We're multiplying, so we add the exponents. 2 plus 4 is 6. That's it. Don't get confused by the negative here. The coefficient is negative, but we don't have any negative exponents yet, so we certainly don't need to use that whole reciprocal idea and flip that down on the bottom and stuff like that. So let's take a look here. We've got a big multiplication problem. Not numbers that look very good, but let's go ahead and multiply these together. And for that, I'm going to grab the calculator. And let's go ahead and do negative 18 times 7. We get negative 126, so negative 126. And then let's see, we normally do these in alphabetical order, so let's do the t's first. So we've got t to the u, and this is, don't forget, that's t to the 1st. So we're going to add those exponents together, so that's going to be 10 plus 1, we get 11. And then we have u to the 12th and u to the 4th. 12 plus 4 is going to be 16. So there's our answer right there. Let's take a look at the next one. Similar, but we've got a few more things floating around here. We've got a negative times a negative. So I am going to rely on the calculator to get that one right. We need to do negative 11 times negative 15. The answer is going to be positive, but let's just double check. Let's type it into the calculator and see what we get here. We get 165. So 165 is that simplified coefficient. And then we normally write them in alphabetical order. This one happens to be backwards, not a huge deal. So G, let's do the G's first. We've got 3 here and 8 here. Again, we're multiplying, so we add the exponents. So this is going to be G to the 11th. And then we've got the H here and the H here. We've got 5 of them here and another 12 of them. So 5 plus 12 is 17. So this is going to be H to the 17th. So we'll circle that. We've got that answer. So we're 9 problems down. Then we get into some interesting ones that you really want to be careful of. So take a look at number 10. It's generally best to do the stuff inside the parentheses first. Simplify that, and then we'll take care of this exponent on the outside. So I'm going to kind of ignore that for the time being. I'm going to kind of cross that off. I know you can still see it. But let's take a look here. I've got a 2 and a 3 and a 15. Well, if you notice, we can simplify this by cross-canceling the 3 with the 15. 3 goes in here once. 3 goes in here 5 times. So then we've got a 2 and a 5, and there's really not much we can do with the 2 and the 5. So I'm going to go ahead and leave that. Then let's take a look at the a's. Again, we've got that understood a up here, a to the first. So this is going to be a to the 5th. 4 plus 1 is 5. And then on the bottom we have a squared. So let's cancel these now. I've got 2 of these that will cancel 2 of those, so I've got 3 left. So this is 2a to the 3rd over 5. And now let's come back here and let's bring back that 2 that was outside the parentheses. So now we're going to square this. So now I'm going to square the 2, I'm going to square the 5, and I'm going to square the a to the 3rd. So 2 squared is 4, and 5 squared is 25. So I'm going to have a 4 on the top and a 25 on the bottom. Power to a power, remember that, we're going to multiply those together, so that's going to be a to the 6th. So we get 4a to the 6th all over 25. We'll circle that and we're done. Take a look at this one right here. Unlike this one where we had the fraction inside the parentheses, here we've got parentheses cubed on the top and then parentheses squared on the bottom. So let's go ahead and figure this out. I'm going to cube 3. Give you a second to figure that out. If you need a calculator for that, go right ahead. 3 cubed is 27. X squared cubed, multiply the exponents, so that's x to the 6th. Y to the 4th to the 3rd, multiply the exponents, so we're going to have to the 12th. And then don't make a silly mistake on these exponents. We certainly don't multiply these together and get 9, and we don't multiply these together and get 12. This is literally 6 squared, so 6 squared is 6 times 6, so we end up with a 36 on the bottom. Take a look at the x's. We've got 14 on the bottom, power to a power, we multiply. And then don't make a silly mistake on this one. Again, that's a 1, so we're still going to multiply these, so we square that on the bottom. Now we want to take a look at what we've got as far as coefficients go. Think about a number that will go into 27 and 36 evenly. We want the largest number that will go in there, and that would be 9. So 9 goes in here 3 times, and 9 goes in there 4 times. So that means I have a 3 on the top and the 4 on the bottom. We've got 6 on the top and 10 on the bottom, so these are going to cancel. That would be 8 left down here, so that's going to be x to the 8th. 2 y's down here and 10 up here. Sorry, excuse me, thinking ahead to the answer. These 2 are going to cancel with 2 of those, so that's going to leave y to the 10th here. And that right there is the simplified answer. We'll take a look at this one. We need to square this first. Let's get rid of those parentheses. Square 4, you get 16. Square m to the 5th, you get m to the 10th. Square n squared, you get n to the 4th. Power to a power, multiplying these. See how we're doubling each one of those. Times by 5, m to the 6th, n to the 3rd. We'll multiply the numbers together. If you multiply 16 times 5, you get 80. We've got 10 here and another 6 here, so that's going to be m to the 16th. We've got 4 here and 3 here, so that's going to be n to the 7th. So there's our answer on that one. Slide down here. We're going to do a similar thing here. This is actually easier than some of the other ones we've been doing. We're just going to simplify this. 9 goes in here once, 9 goes in here 5 times. So that means we've got a 5 on the top. Let's take a look at the A's. 4 on the top, 5 on the bottom. These 4 are going to cancel, leaving 1 down there, so we've got an A there. These 2 will cancel with 2 of those, so that'll be B to the 7th on the top. So we get 5B to the 7th over A. Negative divided by a negative is a positive, so we know the answer is going to be positive. We want to think of the largest number that will go into the 12 and the 8 evenly. That'll be 4. 4 goes in here twice, 4 goes in here 3 times. Again, the answer is positive, so we're going to have 3 over 2. Take a look at those W's. 7 will cancel with 7 of those. We're going to be left with a W to the 3rd here. 5 of those will cancel with 5 of those. We'll be left with a V to the, let's see if we subtract those, so we get 4. So now you could rewrite this if you want, put that 3 in the middle of the top. Either way it's fine, totally okay either way. Now on this next one we're going to get some fairly large numbers because we're going to cube this. We're going to raise this to the 3rd. And then this is going to be raised to the 3rd, so we're going to multiply the exponents power to a power. That's going to be x to the 24th. Multiply the exponents y to the 21st. And this, let's use the calculator. We could try and figure out what that is, but let's use the calculator. And I'm going to put this in parentheses just because it's a good habit. We're going to have one in just a few minutes where you definitely need to put it in parentheses. Negative 729. So we get negative 729 x to the 24th, y to the 21st. And there's our answer on that one. Okay, let's take a look at the last couple on this page, and then we'll flip it over and do some of that scientific notation stuff. Again, this is one that I've been warning you about. You need to be really careful with this because we have 6 negatives. That's an even number of negatives. The answer is going to turn out to be positive. I'm going to let the calculator do the work and just double check and make sure that we get that right. Power to a power we're going to multiply. That's going to be 7 times 6 is 42. Power to a power, we multiply 6 times 3, that's 18. And then let's grab the calculator, and you'll notice that it starts out negative, but as long as I put this in parentheses, which would be a good idea to do every time, this is going to give me a positive 64. So we get 64 x to the 42nd, y to the 18th. And we'll circle that and we're done. The next one's always interesting. Looks like a bit of a mess. We've got a 3, x to the 5th, z to the negative 7. That's our first negative exponent that we've run across here. But you'll notice that all of that is raised to the 0. And any number, doesn't matter what it is, raised to the 0 power is 1. Please don't make a silly mistake on that and say the answer is 0. Make sure you get that right. Another easy one here, not much simplification to do. All we need to do is recognize the 12 is totally okay, the t to the 8th is totally okay. We like positive exponents, but we don't like negative exponents, so we're going to use that reciprocal idea. The negative in the exponent means reciprocal, so we're going to move that down to the denominator, and that's it. All we're doing is moving things around. So let's take a look at this one here. Again, some of those perfect squares, perfect cubes, different things like that, powers of 2, powers of 3, powers of 4. Those are things that are going to come in really handy on this test. So let's take a look here. This is 27 to the 4th and 3 to the 6th. They have different bases, so we can't use the rules that we've been working on. So what we're going to do is we're going to change them both, and it's usually, change this one. It's usually easier to change the big base to the small base. So this is going to be 3 to the 6th here. We're going to leave that alone. But 27 is 3 to the 3rd. So 3 to the 3rd, you'll recall, is 27. So wherever this problem wants a 27, we're going to put a 3 to the 3rd in its place. So we have power to a power. That's going to be multiplying 3 times 4. That's a 12. And then we're going to multiply that by 3 to the 6th. Now the bases are the same. We can add the exponents together. So this is 3 to the 18th, and we'll leave that just as it is. This one we haven't seen before. I don't think we did that on any worksheets, but you should be able to handle this. This is 6 to the 7th, and we did this a few minutes ago. Is there a 6 to some power that we could have equal 36? So I'm going to put the 5 outside. 6 to what power equals 36? And that would be to the 2nd power. 6 squared is 36. So I'm going to write 6 squared here. 6 to the 7th on the top, power to a power, and multiply those exponents, so that's 6 to the 10th. These 7 will cancel with 7 of those, that'll leave 3. So again, there's always a 1 left on the top. If you've got nothing left on the top, there's always a 1 left. And then this would be 6 cubed. I'm fine with you leaving that answer. If you wanted to change this into 1 over 216, then that would be fine. but there we go. Another problem like that, except for this is multiplication. 49 is 7 squared, raised to the 6th, 7 to the 4th, power to a power we're going to multiply, so that's going to be 7 to the 12th and 7 to the 4th, so 7 to the 16th altogether. So there's our answer there. Alright, we'll flip this over, and now we're going to take a look at some scientific notation. Now, we've got a couple different, take a look at the instructions. We've got a couple of different things we need to be able to do. We need to write numbers in scientific notation, and we need to be able to write them in standard notation if they're given in scientific notation. So let's take a look at this. Remember, scientific notation has one non-zero digit in front of the decimal. So we're going to go 1, 2, 3, 4, 5. So we're going to put the decimal right here. So the decimal part of the number is going to be 2.45. And then remember, scientific notation always has that decimal number times 10 raised to some power. And if we're making this number smaller by moving it over to the left 5 places, we're going to make this exponent bigger. We're going to make it positive. So this is going to be to the 5th power. So we've got a big number, positive exponent. Take a look at this one. This is going to be a small number. Let's see how many places we have to move here. Let's see, 1, 2, 3, 4, 5, 6 places. So this is 3.24 times 10 to the, and then remember, we took this small number and we made it bigger, so we're going to need to, when we move that decimal to the left, sorry, to the right, we're going to subtract from the exponent. We're going to make this a -6. So remember, big numbers are represented with positive exponents, small numbers represented with negative exponents. So there are answers on each one of those. And let's do this last one. This looks like it might be in scientific notation, but it's not, because we've got 2 digits in front of the decimal. So we need to go one place over. So this is going to be 1.445 times 10 to the, now we've got to figure out what we did here. We went from 14 to 1.4. So we made this number smaller. So we're going to make this number bigger. We're going to make the exponent bigger. If we make the decimal number smaller, we make the exponent bigger, and we're going to make it bigger by the same number of decimal places that we moved it. So we're going to make it bigger by adding 1. Don't just say, oh, I'm going to make it a 5. That's not the way it turns out. -4 plus 1, that's going to be -3. So in scientific notation, that number right there is 1.445 times 10 to the -3. Let's take a look at this one, standard notation. Again, if it's a positive exponent, we're going to make this bigger by moving the decimal to the right that many places. So I'm going to write 5.67, and then I'm going to go 1, 2, 3, 4, 5, 6, 7. So we're going to fill in these places with zeros. So 5, 6, 5, 0, 0, 0, 0, 5 zeros. Now you might notice we've got 2 decimal places here behind the decimal, and we've got 7. So what that means is once we've moved it 2, we're going to have 5 more places to fill in with zeros. And it's usually easier if we put some commas in the number so that we can read what it is. So 56,000, whoops, that should be a 7. I apologize for that. 67, okay, so 56,700,000. Now we'll do this one. Again, I'm going to write 1.4, and because this is a negative exponent, we're going to move the decimal to the left. So we're going to go 1, 2, 3, 4. Decimals right there. Fill in with zeros. Again, if you count over, we've only got 1 decimal to move, so then we've got 3 more places to go. So this is going to be 0.000, 3 zeros, and then a 1, 4. We're going to circle that for the answer. And then take a look at this one. This one's kind of unique. 3.2, all we have to do is move this. This is positive, so 1 unit to the right. So we're going to go over 1 unit. The answer on that problem is 32. Okay, little unusual, but that happens occasionally. So this says perform each operation, leave your answer in scientific notation. This is kind of a big bonus because that's going to make this a little bit easier to do. So remember, we're going to break this up into 2 parts. We're going to multiply the decimal parts of the number, we're going to multiply the powers of 10, and then we're going to make sure that the answer is in scientific notation. So I would grab your calculator, because most of these are going to require a calculator. So I'm going to go ahead and turn that on and clear it off. So we've got 6 times 2.7. So we're going to do 6 times 2.7. We end up with 16.2, so this is 16.2 times 10 to some power, and this is the easy part. We're going to add those together, -9 plus 5, that's going to be -4, and then we check to make sure that this is in scientific notation. I need to move this over 1 place, so we're going to have 1.62 times 10 to some power. And remember, we made this number from 16 down to 1.6, so we made it smaller. That means we need to make this bigger. That means we're going to be adding something to it. So this is going to be to the negative 3. Negative 4 plus 1 would be negative 3. Let's do this one. Again, I'd have that calculator handy because you're going to be doing this over and over and over again. So we're going to have 5.4 times 1.8. 9.72. That's good news. 9.72. That's good news because that has a one digit and one non-zero digit in front of the decimal. Then we'll do these guys right here, add those together. So we're going to get negative 4 plus 8. That's a 4. Done with that one right there. Let's move on to this one. 1.9 times 8.9, 16.91. So 16.91, and then times 10 to the, let's see, we combine those, we add those together. That's going to give us negative 14. And then we're going to do the same thing. We need to move this over one place, so that's going to be 1.691 times 10 to the, let's see, we made that smaller, so we need to make this bigger. Smaller by one decimal place, so bigger by 1 in the exponent, so that's negative 13. We'll circle that. And then we'll just plow through the rest of these. We're going to divide here. So we've got 1.2 divided by 4. So 0.3, 0.3, and then times 10. Remember, when we're dividing, we subtract the bottom exponent from the top. So 10 minus 3 would be 7. And then we need to move this over here. So we need to move that over one decimal place right here. So we're going to use 3.0. You don't have to put the 0, but I kind of like putting it. That way everybody knows we know what we're doing with scientific notation. We went from 0.3 to 3. So we made this bigger. That means we need to make the exponent smaller. So we're going to make that smaller by 1. So that's going to be 10 to the 6th. There's our answer there. Let's do the decimal part of this problem. Let's do 2.4 divided by 4, and we end up with 0.6. So we kind of end up with the same thing, 0.6 here, and then this would be 10 to the, now remember this, we're going to subtract the bottom exponent from the top, so that's going to be subtract negative 3. So subtracting a negative 3 is the same as adding, so this is going to be 10 to the 9th. And again, we need to move this over one decimal place to make it bigger, 6.0. If we made that bigger, we need to make this one smaller, so we're going to subtract 1, so this would be times 10 to the 8th. Done with that one, and then let's take a look at this one. Hopefully this one we don't have to move anything around. So we've got 6.4 divided by 1.6, and we end up with 4. So I'm going to write 4.0 just to kind of make sure we know what we're doing. And then I've got a 5 minus a minus 5. So 5 minus a minus 5, or minus a negative 5, that would be 5 plus 5. So that's going to be, whoops, to the 10th. And the good news here is we don't have to change anything. This is just going to be 4 or 4.0 times 10 to the 10th. And that's it. Now, at the end of this here, now your test is not going to be this long, but these are things that you would definitely want to know if you're going to do well on this test. So one quick thing would be, what does a negative in the exponent mean? Negative in the exponent means the word reciprocal. So we're going to take things and we can move them from top to bottom or bottom to top to change the sign of the exponent, especially if it's negative. If you raise a number, any number to the 0 power, you're always going to get a 1. And then the last thing is, you don't have to have these memorized, but this would really be a good idea to be familiar with these. You can use your calculator to figure out a lot of problems like this. But you'll notice that when we were doing these problems, especially when we were rewriting using the same base, there are some numbers that you're going to want to be familiar with. And you'll notice that we had some numbers up here where we had negative 4 to the 3rd and 4 to the 3rd. Different things like that. So the more familiar you are with these common powers, the better off you're going to be. So I'm just going to quickly go through and do these. So 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. Powers of 2 come up quite often. Same with the first couple of powers of 3. So this is going to be 3 to the 1st, 3 squared is 9, then 27, 81, and 243. I know some of you have that memorized. 4. You'll notice that these are always the same. If you're just raising a power to the first, so this would be 5, this would be 6, and this would be 7. 4 squared is 16. 4 to the third is 64. We're just multiplying by 4 every time. So here we're going to multiply by 5 every time, so that's going to be 25, and 25 times 5 is going to be 125. Multiply by 6 every time, that's a 6 squared, so that's a 36, and 7 squared is 49. This first row of right here, actually these first 2 rows, okay, those are definitely things that you ought to be familiar with. No doubt about it. Those come up all the time. The other powers, especially for 2 and for 3, come up a lot, but you definitely ought to know these. Those are perfect squares, perfect cubes, stuff like that. Should be a piece of cake, in fact, including this guy right here. Anyway, good luck on the test. If you need to rewatch this, if you need to look at anything, please do. Best of luck on the test.